Hey all, so I'm still having trouble with my Mac, therefore I have to do this on my personal computer. So we're going to be using a whiteboard, and I know some of you have been having troubles with the problems that I showed, so I'm going to do an example problem that's similar but not exactly like the one that is on the work to try to do. So let's pretend you are in a town and there is one person that's infected with a virus. This disease, every person spreads to two other people, which is different from the one that you have where it only spreads to one person. So on day 0, only one person has it. So then this first day, what's going to happen is the disease is going to spread to 2 more people. So in total, there's now going to be 3 different dots. Notice how I'm writing this. This is kind of like how I'm making my table if I was to have to actually type it in the Google Classroom. So this is the day 0 and the first day. Now on the second day, so I'm going on to day 2, this person is still going to infect 2 people. This person's going to infect 2 people. And then lastly, this person's going to infect 2 people. So in total, let's count all our dots. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have 9 people infected. From here, we can figure out a pattern. Note, this is not a linear equation because it's not increasing by the same thing each time. Therefore, thinking about the unit we're in, this is going to be an exponential equation. So instead of keeping and drawing all these dots, because that's going to take me forever, I'm going to try to come up with an equation. Remember from when we did the goldfish activity, we had our y equals a times b to the x. Also, if all of this is backwards, I'm sorry, I don't know how to fix that. So I'm working on it. So where y, as normal, is our output. So what we get out of everything, A is, when we think about it, it's our start value. It's our initial value, our y-intercept. B is our multiplier. And X, as always, is our input. So if we look at our table, we have to say, I'm going to write it in a different way just so we can see it easier. So I'm actually going to make a table. 1, 3, 2, 9. It looks something like this. So we have to think about, because it's exponential, that means we're multiplying by something. And from 1 to 3 and 3 to 9, that means we're going to be multiplying by 3. That's our pattern. Then remember, y-intercept is always when the x is 0. So that means our a value is going to be 1, and our multiplier is going to be 3. So we now have the equation y equals 1 times 3 to the x. From here, you can fill out the rest of your table just by plugging in the x. So if x was 4, you would have y equals 1 times 3 to the 4th power, and so on and so forth. So that should cover the first 2 questions. The third one, you have to use your table to analyze and figure out where would they have that 200 people that are infected. The very last problem wants to know the exact amount of time. So the third one is just a guesstimation about, like, okay, after this many weeks, everyone's infected, or that many people's infected. The very last one wants to know when it is exactly that many. So let's say in this town, I want to know when 100 people are going to be infected. That means it's going to be my output is 100. So I go back to the equation I wrote, and I would have 100 equals 1 times 3 to the x. So this is an exponential equation. So this goes back to what we were learning about logs and exponentials. Because to be able to solve for x, we have to take the log. So first we have to get this alone. Anything divided by 1 is just 1, so I'm just going to erase that. So remember, there's those two ways we can solve from here. We can either solve by taking the log on both sides or by rewriting it in logarithmic form. So just a reminder how to do that. Sorry, let me reposition myself. So we circle our base. Our base is always going to be where the exponential is, and we move it to the other side. Because we're changing the form, it's no longer going to be exponential, but it's going to be logarithmic. So now I have log base 3, because 3 stays your base, of 100 equals x. And we're like, okay, cool, I remember that part, but I don't remember how the heck I figure this out. So I actually need my phone to show you how to do this in your calculator. Give me a second. I lost my phone. Just kidding, I found it. Okay, so remember we use change of base to put this in our calculator. So change of base is where we divide the log of the top divided by the log of the bottom. So in this case, I'd have x equals log of 100 divided by log of 3, because 3 is our base, so our base goes to our bottom. On your phones, when you're doing this, you're used to just using the calculator where it's like this, and you can't see it. But what you want to do is you want to make it go sideways, and then you'll be able to see the log button in your calculator. If not, you can also just go to Google and type in log 100 divided by log 3, and that'll get you your answer. Remember, when you get your answer, to round it to 4 decimal places, so have 4 little numbers after the decimal place. Remember, this is just an example problem. This is not like the one that you have. You will have different numbers, but it is very, very much close. So again, I hope you all are doing fine. I hope this example problem helps. I'm going to try to get other videos and stuff for now from other people. I just couldn't find one that I liked to help you with this. So hopefully nothing is backwards as well, which it probably will be. But we're going to work through this together. Remember, if you have any questions, concerns, not even math-wise, whatever, reach out to me. You have all my numbers. Have a super good day.